Hello everyone and welcome to Mydbops MyWebinar Edition 31 on the topic Scale your database traffic with read-write split using MySQL Router. My name is Shiny and I'm excited to be your host for this insightful webinar. We are very happy to have you join us today. I'm immensely proud to represent a company that has been actively contributing to the open source database community, and I would like to extend my heartfelt gratitude to all of you for your continued support in our journey of contributing to open source databases. About Mydbops, founded in 2016 with over 8 years of experience, we have built a strong reputation for open source database excellence. And we have grown into a trusted database management and consultancy provider with over 800 satisfied customers. And we are proud to be an AWS partner, and we are PCI and ISO certified, ensuring the highest security standards for your data. And we have monitored over 6,000 servers for more than 300 happy clients, ensuring their databases run smoothly and efficiently. Our team has successfully completed over 120 complex database migrations, seamlessly transitioning clients to new environments. A team of experts offers a comprehensive range of services to meet all your database needs, whether you need consulting or managed or remote DBA services. We specialize in a variety of open source database solutions, including MySQL, MariaDB, MongoDB, Postgres, TiDB, Cassandra, and more. Today, we are focusing on MySQL Router, a powerful tool that can significantly improve your database scalability and performance. So, in today's webinar, you will learn how MySQL Router can optimize your database performance and scalability, and the key benefits of using MySQL Router, including transparent routing, high availability, and read-write splitting. And you will also learn different use cases for MySQL Router with a focus on static and dynamic read-write splitting for various database setups. And finally, a comparison of MySQL Router with other popular load balancers. And attendees, feel free to ask questions throughout the presentation in the chat section. Our presenter Vignesh Prabhu, a database reliability engineer at Mydbops, will be happy to address your queries. So without further ado, let's get started. I kindly request Vignesh to take this virtual stage and begin sharing his valuable insights with us. Vignesh, over to you.
Yeah, thanks for the intro, Shiny. Yeah, hi guys. So this is Vignesh Prabhu. I'm working in Mydbops as a database reliability engineer. Today we are going to see about MySQL Router and how we can scale our read traffic and write traffic using that, and how the read-write splitting is working in MySQL Router. Yeah, and before going to this is a short intro about ourselves. So we founded in 2016, and we have like 800 plus happy customers. This is going to be our agenda. So first introduction, we'll start with introduction and features of MySQL Router. And we are going to see about routing strategies and few use cases of MySQL Router. And we are going to finally compare load balancers which are available in the market. Yeah, so basic introduction of MySQL Router is it's a part of InnoDB cluster, and it's purely for high availability solutions. So it will work for InnoDB cluster and InnoDB cluster replica set, and it lacked as a transparent routing between application and backend MySQL servers, and it is easily scalable based on our MySQL clusters. Yeah, so why we have to go for a MySQL cluster? So the main thing is like auto failover. So whenever like we are choosing for a clustering solution in DB, so we are going because of a high availability solution. So our router also needs to be like highly available, and it has to be auto failover. So here in our case also, MySQL Router will automatically failover whenever the primary or secondary changes. And whenever a new node is coming, it will automatically add a node and it automatically removes the node from the MySQL router connections. So based on that, the connections routing will be happen. Yeah, so these are the features of MySQL router. So it works as a, like the routing is based on a completely like transparent routing, and it is highly available for InnoDB cluster and cluster replica set, and it will balance the load, it will balance the connection across the available nodes in the cluster. And we have a routing strategy which is available from the version 8.0.4. So we can able to choose the routing policy for each destinations. And we have a new feature which is available from 8.0.8.3, that is a read and write split, and automatic failover. As we mentioned earlier, like automatic failover is a main functionality. And yeah, so when coming to bootstrap configuration, so we can able to like easily configure our MySQL router for our InnoDB cluster and replica set. And yes, it is cross-version compatibility. We can able to use a higher version of a MySQL router with lower version of MySQL, and vice versa. We can able to use a lower version of MySQL router with a higher version of MySQL as well. Yeah. So we are going to see about the routing strategy here. So before going to routing strategy, let me tell about this destination. So on each tag, we can able to mention the destination. So in the destination, we have to mention the servers which are available for that tag. Yeah. So here routing, we are going to discuss about the routing strategy. There are 4 types of routing strategy which is available. The first one is first available, second one is next available, and round robin. Finally, round robin with fallback. So let us discuss more about these routing strategies. Yeah. So this is first available. So how it will work is like, consider we have a three separate nodes, standalone nodes, and all the nodes are available, and in the order of 196, 200, and 205. So for the first available routing policy, what will happen is like all the connections will directly go to the first node, that is 196. So in case 196 is going down, it is not available. What will happen is like it will go for the next server, whatever we have mentioned in the destination. So that is 200. And whenever the 196, the first server is coming back to online, so all the connections will be routed again back to this 196. So this is the first available routing strategy. Next, we are going to see about next available routing policy. So here it is almost similar to first available, but what will happen is like, so whenever a first node is going down, uh, it will route the connection to the next server. Whenever the first server is coming back again to the online, it will not route back to the 196, that is the first server. It will stay in the second server itself. So this is the next available routing strategy. So next one is round robin method. So from the name itself, we can able to understand what it will do is like it will route the connections for one by one the servers. So for first connection, it will go for the first server. Second connection will go to the second server. Third connection will go to the third server. In case if any one of a node is going down, it will route the connections to the remaining 2 servers one by one. Yeah. So next we are going to see about round robin with fallback. So round robin with fallback is similar to round robin, but so whenever all the nodes are going down in that 3 servers, so there will be a primary server definitely. So what will happen is like, so it will fall back to the primary. So all the connections will be fall back to the primary server. But in the round robin routing strategy, so whenever all the nodes are down, it will not direct any connections. It will throw a error through the application. But in the fallback, it will route the connection to the primary server. So, so let's see about a few cases of a MySQL router and how it is working. So the case one is like, we are going to see about how we can use MySQL router in master and replica servers. So this is going to be our infra. We have two masters with three replicas. So this is how we have set up our initial environment. So we have a master setup, and under the master one, we have three replicas. So the first thing is like here for MySQL router, after installing that, we have to manually configure the read-only and read-write. So we so as we mentioned earlier, like what we can do is like we have to mention the destinations for the read-only tags. So we can mention all the replicas in the read-only tags. And for the read-write tags, we have to mention the master one and master two. And MySQL router will work based on ports actually. For read only, we can use separate ports. For read write, we can use separate ports. For application actually, like which is having a master and a replica, I mean this read and write split is, so it will work effectively. Yeah, and this is going to be a static configuration. So whenever we are adding a node, we have to add that we have to add the new node into the destination. So that will be this main limitations. The advantages are so transparent routing we can able to do, and we can able to do the read write splitting for the static destinations. So it will not update automatically. So limitations are like we have to do the configurations manually, and the automatic failover is not available, and we have to use separate ports for read and write. So if we have an application like which is having like both read and write in a same service, actually like it will be very difficult. Yeah. So the next case is dynamic read and write with InnoDB cluster. So this is our infra, second infra. So we have a three node of cluster, InnoDB cluster. On top of it, we have a MySQL router. So this is the environment we have taken. And unlike our initial case one for a static connection, so here actually what we can able to do is like we can able to configure the router by a single command itself. So this is called bootstrap. So using this MySQL router bootstrap command, we can able to bootstrap that MySQL router. So what it will do is like it will create a files under the MySQL router configuration. So these are going to be the files and directories. So the first one is start_start.sh. So how it will use, like we can able to start the daemon process of a MySQL router for the InnoDB cluster. And similarly, using stop.sh, we can able to stop it. And MySQL router configuration is for automatically it will create a router configuration, read, write, all the tags it will be automatically created. And whenever we are bootstrapping it, it will get the primary information from the InnoDB cluster, and it will store that information in the /data and state.json file. And yeah, this one is for logging purpose. So log folder will hold all the logs of the MySQL router. Yes. So next we are going to see about see this MySQL config file in detail. So after we bootstrap that MySQL router, it will create the below config file. So this config file will have read, write, and read only automatically configured. And the ports are also like by default for read, write, it will have 6446, and for read only, it will have 6447. And the destinations, we don't need to mention it manually. It will automatically get from the metadata cache. And metadata cache will be updated frequently. And routing strategy, we have already discussed. And primary, like for the read write, it is first available. And for read only, like it is round robin with fallback. So whenever secondary servers are going, all the secondary servers are going down, it will automatically fall back to the primary. Yeah. So from 8.0, from 8.3, MySQL router introduces that read write split automatically. So what will happen is like whenever we are doing that bootstrap, it includes the read write split tag also. So what's special in the read write split is we can able to use that we can able to do the read write split in a single port itself. So using 6450, we can able to do the read write split. We can able to direct our connection, and internally MySQL router will do the read write split across primary and secondaries. And there are few conditions uh, for for read write split is there. So let us see about the conditions and the requirements actually. Okay, yeah, to enable the read write split, so connection sharing should be enabled. So connection sharing is nothing but it's a connection pooling. So it will MySQL router will automatically create few connections into the DB, and it will repeatedly use that connections. So to avoid frequent connection spike and connection down, so it will use the connection pooling. So destinations should be metadata cache. It means that we cannot use this read write split, automatic read write split for static, the use case one we have discussed. And protocol should be classic. It means like we cannot use a X protocol, and server and client SSL mode should be in a preferred state. So it will automatically choose whether it is a encrypted and or unencrypted connection. It will automatically accept it. So these conditions will be uh, automatically deployed by the bootstrap function itself. We don't need to worry about that. But if we are deploying it manually, like we have to be sure that for read write split, connection sharing is the main thing which we have to enable. Yeah. So advantages in this method is bootstrapping. So with a single command, like we can able to start working with that MySQL router. And second one is automatic failover for HA system. For InnoDB cluster, if primary is going down, and primary will be automatically elected within a cluster, and that information will be passed to that MySQL router within milliseconds. And destinations, we don't need to change it actually. If any one of a node it is added to the clusters, and based on the cluster site cluster details, like it'll automatically add that destinations. And yeah, so it has a native support for read write split also from 8.3 MySQL router. Yeah, so next we are going to see about case 3. So there will be few customers like they don't have a clustering technology. They are still stick with that initial like MySQL master and replica strategies. So for their requirement, MySQL has introduced a InnoDB replica set. So InnoDB replica set is nothing but a master and replica, and it will be administered by a MySQL shell. So that is a InnoDB replica set. So this is going to be our next infra. So we have one source and one replica. Yeah. So here we can able to see this is a asynchronous replication, and first server will be like primary, and second server we can able to see secondary. We can able to see that modes also. Here it is read and write, and here it is read only. So how we can implement MySQL router for InnoDB replica set? So here also same thing, like we can able to use a bootstrap. So using that, how it will do is like it will automatically get the replica status and master status from the router, it's from the MySQL shell itself. So how it will do is like it will after we after we enter the bootstrap functions, it will similar to the cluster InnoDB cluster. It will configure this 3 tags. One is read write, and another one is read only, and another one is read write split. So the configurations will be similar to that InnoDB cluster. So one thing which we can able to see is like the destinations. So the metadata cache it will get from the InnoDB replica set. So whatever the primary, it will go primary will. So the writes will be going to the primary, and whatever the secondaries, all the reads will be going to the secondaries. And whenever the secondary is not available, it will be automatically the reads will be automatically fall back to the primary based on the default routing strategy, round robin with fallback. And also like similar to this, we can able to do an automatic read write split using the MySQL router itself. If we connect our application in 64550 port, it will automatically handle that read and write. So the advantages are similar to InnoDB cluster. Only one limitation is that uh, we have to manually do a manual failover whenever a master is going down. So we have to manually do a failover using a MySQL admin API. So after that, it can able to MySQL router can able to fetch the data of metadata cache from that InnoDB cluster set, and it'll automatically update to that inventory. Yeah. So next, we'll see about the demo of router with InnoDB cluster, how it is working. Yeah, let's go to the demo. So here we have taken 3 node of cluster, which we have already set up. And along with that, we have taken a node for MySQL router also. So let us check for the status of InnoDB cluster. Just connecting to the shell. Let us connect to the MySQL. Let's get the cluster details. Yeah. So yes. So here we can able to see there are 3 nodes, 174, 181, and 227. So in the 3 nodes, one node is primary and other 2 nodes are secondary. So this one is the first node which you have connected from MySQL shell. And the second node also, I'm just checking the status. Yeah, all the nodes are available. So all the nodes are available. So here we are going for the MySQL router node. So we have already installed a MySQL router in it. Have installed the packages. Yes. Uh, Here we have the MySQL router package. So what we are going to do is like, as we mentioned in that presentation, we are going to create a directory and we are going to bootstrap it using a MySQL cluster IP. Yes. So it has created MySQL read write connection for the 6446 and read only connection on the port 6447, and read write split will work based on in the 6450. Let us go into that directory which we have created. MySQL router paste. Yeah. So these are the files which it has created automatically. Yeah, let us go into this MySQL configuration. Before going to the MySQL configuration, let me show you that data. So data will have that state file. So this will have the initial information, primary information of cluster. Yeah, so these are the 3 nodes which are available in the cluster, and it will hold that group replication ID also. Okay, so it has created this MySQL router configuration file automatically. So let me show you that. Yeah. Here, if you see, it has automatically created 3 tags. One is read write, another one is read only, another one is read write split. Uh, yeah. So read write is based on like first available, and read only is based on round robin with fallback, and read write automatic split is based on round robin. So let us see how it is transfer, how it is routing that in connections. Okay, I'm just so 6447 is the port for read only. I'm just going to connect in that. Okay, so before connecting to that, we have to start the router process. We are going to start it. So it has went to the daemon state. Okay. So let us see the log which it has created. Yeah, so here we can able to see the three nodes which has automatically mentioned like after we have started that process. So 181 is the read node primary and other two nodes are secondary. So let us tail this error log. So meanwhile, in this tab, so I'm going to connect to that read-only port. So yeah, it has mentioned as a round robin. So 6447 is a port for read-only. So read-only is as if you see 2227 and 174. These two nodes are in read-only. So if you mention select host name, at first time it is routing to 227 and at second time it is routing to 174 as mentioned by the round robin fashion with fallback actually. So what we are going to do is like we are going to test out a fallback whether it is working fine or not. So we are going to stop the two secondary nodes. So I am with the secondary node 227. I'm going to stop the replication in it. So I have stopped one secondary node. So if you see in router logs, it has mentioned as this 227 has went actually like down out of the cluster. So the mode actually like went to null. So let us see how the routing works. Yeah. So even if we trigger multiple connection for the read only, it is going only for the available 174. Let us check for fallback. It is working fine or not. Let us stop another secondary node also. Okay. Yeah, another secondary node also stop. Yeah, if you see in the log, so it has mentioned as 2227 and 174. Both the read-only nodes, secondary nodes are down actually. Let us check the connections for the read-only. We'll check whether the fallback is working or not. Yeah. So yes, so it has routed the connection to the 181, which is a primary. So yes, round robin with fallback is working fine. So yeah, similar to this, we can also check the 6450 code. So 6450, we can able to do all the operations, including read and writes, everything we can able to do. So now we are doing a select. So since only this primary node is available, it is going to the primary node. Let us start the two secondary nodes which we have stopped. Okay, I'm starting the second node. Okay, I'm starting third node. Yeah, so all the nodes are in online now. Now, if we check the read-write split in a single port, yeah, so select is working fine. Let us try creating a database, test database. Router. Yeah, it is working fine. And if we give show schemas, yes. So using 6450, we can able to like automatically we can able to do a read and write operations actually. Yeah, thank you guys. Let's go for the next slides. Yeah. So finally, like we are going to see about the comparison between the load balancer, which are mainly available for MySQL. So the first one is MySQL Router and Proxy SQL, and finally MaxScale. So the first feature is like easy setup of bootstrap function is available on MySQL Router and Proxy SQL. For MaxScale, it is not available. And auto addition of clustering nodes will be automatically detected in MySQL Router and Proxy SQL. MaxScale cannot detect it. And so InnoDB replica set is a high availability solution for master and slave, master and replica itself. So that support is there only there in MySQL Router. And even this addition of replica set nodes can be automatically detected and added to the MySQL Router. And these functionalities is lagging in Proxy SQL and MaxScale. And when coming to like load balancing based on connection, it is available on all the load balancers. And load balancing based on weight, it is available only on Proxy SQL and MaxScale. Still, MySQL Router is lagging behind on that. And similar to that, Regis and the Regis based routing and query caching is available on Proxy SQL and MaxScale, and that is still not available in MySQL Router. So yeah, from this we can able to understand like MySQL Router is especially for designed for InnoDB cluster and especially designed for the cluster set replica set, InnoDB replica set. Yeah, thank you guys, and I hope this presentation helps you a lot in understanding the MySQL Router and the routing technologies of present in the MySQL Router. Yeah, thank you.
Thank you, Vignesh, for your wonderful presentation. So, in this session, we explored how MySQL Router can be a valuable tool for optimizing database performance and scalability, and how it simplifies database architecture. And we also compared MySQL Router with other popular load balancers. I hope this webinar equipped you with valuable knowledge and actionable steps to enhance your database management strategies. Don't hesitate to revisit the recording for further reference. A big thank you to Vignesh Prabhu for his expertise and for sharing his knowledge with us today. And all your queries in the chat section have been addressed. And if you have any other further questions or would like to continue the conversation further, feel free to reach out to us at info@mydbops.com. And please don't forget to send out a review of this webinar on LinkedIn, Twitter, Insta, and other social media platforms for supporting MyDBOps open source activities. Once again, on behalf of MyDBOps, thank you all for being a part of this insightful webinar. Have a great weekend. Thank you.